Hello everyone, Cindy here. This is my 5th attempt, so hopefully it works. Today we are going to be learning the basics of graphing reciprocal functions. So before I start teaching you guys, please keep in mind that I want you to graph the way your teacher wants you to graph because they have certain requirements, and I don't want you guys to lose marks because of the way that I personally graph. So with that being said, let's start with learning how to graph. So let's take a look at this function, f at x equals to x squared minus 1. So we are going to graph the reciprocal function of this graph. But before we can graph the reciprocal, we need to know the equation. And this is really easy because the equation for the reciprocal function of x squared minus 1 is simply 1 over x squared minus 1. And that's because the reciprocal of any function, with the function being f at x, is 1 over f at x. So now that we know the equation, we can actually start to graph our reciprocal function. And so the 3 steps that I like to use whenever I'm graphing the reciprocal function is 1, find out where f at x is equal to 0, and you draw a vertical asymptote. So what I mean is, in your original function, whenever the points where they intercept the x-axis, so as you can see, I put them in orange over here. These are the places where you guys, where there's a vertical asymptote in your reciprocal function. So I'm just gonna quickly draw these lines, just saying that there's a vertical asymptote right over here. So now that we know where the vertical asymptotes are, we're gonna go on to identifying all the invariant points. And so in a reciprocal function, before you identify the invariant points are points that remain unchanged. And basically, it's when the original function intercepts the points where the original function and the reciprocal function remain the same. And so, wouldn't you agree with me if I were to say that y, being f at x, equals to 1 over y, so the reciprocal function? If we were to solve this for y would be positive or negative 1. And that's why all the invariant points between your original function and your reciprocal function are the points that lie on this line, on the line of y equals to 1 or y equals to negative 1. So these are the invariant points of the reciprocal function and the original function. And so now that we identified all the invariant points, we are going to now draw the graph from the invariant points. Now, before we start to draw the graph, there are these basic rules of thumbs. So the first thing is where f at x is equal to 0, 1 over f at x is undefined. And this is just seen through our vertical asymptotes over here. Where the roots are, there's a vertical asymptote for your reciprocal function. Another thing is when f at x increases, the reciprocal function either decreases or goes towards undefined. And this is similar to whenever the original function decreases, the reciprocal function increases or goes towards undefined. In other words, it's the opposite for reciprocal functions. And so now that we know that, we can actually start graphing this out. So another thing that may help you with graphing is that you know that lines, they always go towards. Whenever there's an asymptote, the line is always approaching the asymptote, but it never goes to the place where the asymptote is. So, if we remember all of the rules of thumbs, from the original function from left to right, this section here from the invariant point is decreasing. And so that's why, and since there's an asymptote here, this line for the reciprocal function is going to go towards the asymptote and increasing. And this is kind of the same for this side as well. Now, if you look from here, from left to right, the original function is increasing. And so from this invariant point here, it's going to be decreasing from left to right. Now, notice how I'm not going onto the x-axis. That's because there's actually a horizontal asymptote here, but you won't really know that unless you use extreme values to calculate it, or if you just simply know the properties of it. But you could always use your calculator. And so since that side looks like that, this side looks the same as well. And so now we have another invariant point here. Notice how the original function, this is increasing. So if we remember this to certain properties, you know that this is actually going to be decreasing here towards the asymptote, but never touching it. And that is how you graph a reciprocal function. Anyways, I hope this makes sense.